Hey everyone, welcome back to another live Q&A here from Devoxx Belgium. Today with me I have Per-Ake Minborg.
Yeah.
Per, do you want to quickly introduce yourself?
Oh, so my name is Per and I work in the core library team, working in mostly Panama, and what we are going to talk about today, like LazyConstant.
Yeah. Right, so LazyConstant is something that if you're very up to speed on everything, you might have already heard that. If it doesn't quite ring a bell, you might have known that as StableValues, which is in their first preview in JDK 25, so that's maybe the context in which you heard this. They are now evolving into LazyConstant in 26, and also a bunch of API changes that I saw in the JEP. But before we get to all that, let's start with why. Let's start at the motivation. And having read the JEP, it's there's two poles, which is mutability/immutability, and then optimizations through finality. And maybe we start there.
Yeah, so we have this tension between, final fields and mutable fields. Mm-hmm. So in one hand, you want them to be final because you want them to be optimizable. If something is final, it doesn't change, and then maybe the VM can give you some performance tricks that runs faster. On the other hand, mutability means that you can set it later. But then you give up everything about performance. So you have this tension, and thus you have to, choose one, lose one situation. That's not so good.
Yeah, but it's not only, you talk about from the performance perspective, but also for me, I'm the kind of Java developer who thinks like, performance good enough.
Yeah.
People like you will do the magic, it will work.
Yeah.
So for me also, I want stuff to be final because then I know it can change.
Yeah.
Like, it's good for correctness, but again, maybe I need to assign it later, and then I cannot have a final field if I assign it a bit later. So
I guess you're right about that. But the semantics of final, you give yourself a kind of mental model that, well, I'll set this, now I can forget about it.
Yeah.
It's there, it's set.
Yeah.
So if we take a step back and look at mutable fields to start with, they seem great if you start to look at them in the beginning, but once you start scratching on the surface, you realize there's a lot of problems associated with mutable fields. So for example, if you have an object that contains mutable field and you have that as a parameter to a method, and you have to check invariants, maybe you have a point and you want to ensure that it's in the first quadrant, for example. But if it's mutable, you first check that, and it's mutable, then you can change it underneath.
Yes.
And that is the time of check, time of use problem, which is a kind of a generic security problem that's been around for decades.
Okay.
So that's not good. But it's getting worse because if you have a mutable field, you create an object and then you share it to another thread. Mm-hmm. That thread can observe the first object in pretty much any state. Yeah. It's not that, well, maybe it's not set or it might be set. The order is not totally unspecified, so you can observe out of thin air values. Yeah, maybe we should talk about that a little bit, because at first glance it seems like just bad design. So specifically what can happen is that you say, like, I set this field, and then I'm going to pass this object off to another thread. Yeah. And then that thread might actually, but you think like there's clear order, right? Yeah. But that other thread might actually see the value before it was set. Exactly.
Which seems broken, but it is intentional. It seems broken,
but it's actually intentional design, because you can change the order in which things happens within a thread. Yeah. That's totally okay, because if the thread cannot observe any difference, you can do all sorts of optimization. The compiler can optimize, even the hardware can optimize, and doing things in another order. But there's no guarantee that the thread comes in from the side will observe the right thing. And if we allow this kind of weird behavior, we gain a lot of performance. So if we would have ensured thread visibility for every step, the performance in Java would be crappier. Yeah. So it's a good choice that we did this, but you must be aware what's happening of this trade-off.
I think for this specific situation, wouldn't be volatile be the solution?
Volatile
field would be volatile, and
you can do the volatile, but then it's slow.
Yeah, exactly. But because that enforces the order then,
exactly.
Right?
So for maybe you have 5 fields and they're all volatile, then you have to do this check for every step, and then it's we'll observe that change in another thread, totally okay. Yeah. But slow. Yeah. So that's the trade-off, but there are tricks you can do. For example, you can declare a field final. Yeah. And if you declare it final, it's not only that you cannot only set it once. With the semantic of final fields, you get this kind of something called memory barrier at the end of the constructor. Mm-hmm. And that barrier says that every store that's happened before this barrier cannot be interchanged with stores after the barrier. Mm-hmm. And that means that And the trick here is that the actual reference to the new object itself is created before. So when you observe that, you know that everything that is set in the constructor is visible. So either you can observe the object in correct states, or it's not even set yet. And then you just get null if you try to observe this newly created object somehow. So that is a guarantee you get.
Yeah.
And that's great, but the drawback is that you have to set the final fields in the constructor or in the static initializer.
Yeah.
So you have to pay a price for that. And that creates this kind of tension of immutability is great, but you can't do it later.
Yeah.
So in this space, we thought that, we have thought about this for a long time, we need to come up with something better. Mm-hmm. So in 25, we have previous stable values, which now is called LazyConstant, which is basically the same thing. And you can create a LazyConstant saying that, oh, here's a LazyConstant of type, let's say, integer, and then you provide the recipe as a lambda for that. This is how I want it to be created. Mm-hmm. And it doesn't get computed. Yeah. But it's only when you apply get operation on it, when you invoke this, usually a lambda, and it gets computed and it gets initialized. And after that initialization, the VM magically knows that this value can never change.
Okay, because that, I mean, that's a great part, because until then I would say, like, look, I'm not sure why you're wasting your time with this. I built this like a decade ago from my own code, right? Yeah, so like exactly. a lazy like that is super useful.
Minimize supplier or whatever you call
exactly.
it.
So I built this after it, of course, because I need lambdas. I used lambdas. So like a simple lazy, if you ignore thread safety, a simple lazy is super straightforward. Just like it's a field for the value, it's a field for the lambda. The first get checks whether the field is assigned, and if not, run the lambda.
Exactly.
So then, if you want to make this thread safe, it gets a little bit more complicated. If you want to make it thread safe and always perform it in the not contentious case, it gets even more complicated. But that is all something that somebody on the outside can totally write.
No,
the reason why you wrote it is for...
It's only we that can do such a thing, because it relies...
No, the last step I think is one that only you can do, right? Like where this is then...
The performance stuff.
Guarantee where it's...
Exactly. Yeah. So the secret sauce here is an internal annotation called stable, @stable. Mm-hmm. And of course, you can annotate your custom class with stable, but it doesn't mean anything. It will not have any effect. It's only in the internal JDK that it will have any effect.
Oh. And so you basically, when you see the annotation on non-JDK code, it just doesn't...
It's a no-up.
Okay.
Nothing happens.
Okay.
So that's sad. And we want to bring that in a safe way to third-party developers and application providers, so they can enjoy the same benefits as we do.
Yeah.
Why shouldn't they? So this is kind of a democracy revolution, if you can say, in that sense as well. We want to make it available, but in a safe way, because you can, just as unsafe, you can abuse this stable annotation, because if you set it to a value, the VM sees it, constant folds it, and then you set it to another value. What happens? You get an inconsistent state. Yeah. So we need to protect users from that. And of course, if we do it internally in the JDK, we know what we're doing, hopefully know what we're doing, and we can prevent that in, we can, maybe in some cases we're going to allow races if they produce something that is, exchangeable, means the same thing, or we can do a mutual exclusion.
Okay.
But this comes with mutual exclusion. So it's guaranteed that this lambda is only invoked once, even though several threads are racing to initialize it.
Yeah.
So that's a guarantee. And it's also a guarantee that you can never set the value twice, because you can only invoke it once. Yeah. And if it throws an exception, it just gets propagated, and the next invocation will retry the lambda again. So it will not internalize the errors, it will just retry, and it gets thrown. Everything that's thrown will be thrown to the call side.
Okay, so that means that the lambda... I was wondering, though, whether the lambda gets, the field that holds the lambda, whether that gets nulled out.
Yes, it does.
It does.
Yeah, so that's good. It doesn't hold a strong reference
to
the lambda once it has done its job.
Right, because otherwise the lambda, because if the lambda is capturing, then you would potentially have like drag around instances that you don't need anymore. It's a memory leak, basically.
Yeah, exactly. So that's important. And then that's the thing we added from 25 to 26. Okay. So now it gets removed. And of course,
there's. But that also means that the field for the lambda cannot be final.
That is true. It's volatile.
Okay, because going full circle. Okay.
Yeah, because you can set it from one thread, it gets invoked in another, so therefore it has to be volatile. Yeah. Because we need to see everything there. So this is really complicated. You have to really understand the Java memory model in order to do this. Okay, there is one drawback, of course, because now for every field you have to create a lambda, and creating a lambda is, expensive-ish. So, I mean, if you are creating a file or something, it doesn't matter if you create a lambda, but if you're doing something, shorter, you don't want to create a lambda for each and every LazyConstant, for example. So therefore, we have also added lazy collections. So you can have a lazy list, or you can have a lazy map.
Okay.
And a lazy map is a generalization of a non-evicting cache. So I can just say, I have this kind of inputs here, A, B, and C, and D, and when I need it, here's the recipe for creating them.
Yeah.
And maybe you never create them. And that's fine, because then you don't have to create them. Or maybe you create them later on, and then they get created, and they can be constant folded. So you can get the best of two worlds.
And that's also something that is one of the changes to 26 as well, right? That has been moved around. So this capability was there before, but it was on the, back then, StableValue type, but now it moved to the list, for example, interface.
Exactly. Right? So we decided to move them to a list of lazy, and map of lazy, in order to improve the discoverability.
Yeah.
I think people reach for map dot when they want to create a map. So that was the logical step to put them. And I also think that we intentionally didn't do that in 25, because that was the first preview. We weren't really sure about how people use it, where is the right place to put it. But now we have matured a bit. And another thing we did in a change from 25 to 26 was that we removed a lot of APIs around StableValue, had more methods, imperative methods.
Yeah, I was going to ask about that. So, but before we get there, I want to say that I think this really shows how the preview process is. Like, I think this step shows really well how the preview process can work, where you develop a new capability and it had a lower level name, right? StableValue is more like aligned with the stable annotation, and it had like all of the features like on this one type. And as it matured, as you said, like you found like maybe the abstraction can be like just the naming abstraction can be on a higher level. Maybe the functionality doesn't only need to be centered around this one type. Maybe actually the laziness of the list should not be discovered through the lazy value path, also through the LazyConstant path. Maybe it should be discovered through the list part. So it really shows how the API can evolve through the preview, through feedback, through internal and external experimentation. So let's get back to those methods that you said that were also removed in 26. I recall those were, so the initial JEP, the one for 25, the talk about stable values, basically started with telling, here's how you create an empty stable value, and then you set it on the first access. And I thought, I was like, this is just terrible. And then later it said, like, oh, there's also Lambda. And I thought, yeah, that's what I want to use. Why is that not the first thing you presented? And so I really when I talked about that, for example, in the video, I only showed the second part.
That's
I didn't even tell people about the first part, because I thought, that's weird.
You were behind of us. That's good.
Because I did the lazy a decade ago.
Yeah, I think you're right. And I think that was a part of the exploratory phase. And what we came to the conclusion that the imperative methods were, one, not used by that many people. I think this Lambda stuff covers 80%. And two, when you really want to use them, it wasn't really great, because let's assume you want to have a lazy value of int, for example. Then you have one wrapper. We have to use a wrapper class, because you can't manage primitive classes. And that is wrapped in itself into what was used to be a stable value. So I think we need something more low level. And what that is going to be, we will see. But we are working on it.
Okay.
So we are looking at something that can work directly maybe on fields, and still provide the semantics of stable reasoning in a good way. And we think also that that will make it more amenable to use in internal JDK code, and also by third-party library developers.
So I want to backtrack, by the way, on all the terrible. So I really learned through observing JDK development through like the last 5 to 10 years that when I have a reaction like that, I'm usually very careful with expressing it, because I know that there are very often cases that I do not have like on my radar. Just because I think there's a terrible API that I wouldn't use that way doesn't mean that there isn't another angle. And so to me that usually is a signal to, at some point try to reach out and ask, or maybe see how it evolves, right? In this case, it seems like my gut feeling was on, but often, very often it's not. Very often I have this reaction like, and then it turns out, no, there's actually a good reason for this. So I want to backtrack a little bit on that one. Maybe let's talk before we call it a day. Let's talk a little bit about when people should consider using this, because theoretically I could just now, all my fields could be instead of type, they could all be of lazy value of type,
of course.
and everything is lazy, but that's clearly not the intention.
Let's put down the poll here and say that you should never do that.
Yes.
Don't use your lazy constants everywhere.
Yes.
It's only when you have this, imbalance of it takes a long time to create something, or it's unlikely that it will ever create it. It's only then it makes sense, I think, to have it in a lazy constant. Otherwise, you can just, initialize it. If you know by 100% that this is going to be used, and you know that it's fairly, cheap to compute it, just compute it.
Yeah.
Don't, take this detour around lazy constant.
Yeah.
But in the other cases, like if you have a long list of, potential values or a map with 100 different values, maybe for, different threads, and you just run it in one thread, and maybe just one object is created, and that's great for startup.
Yeah. So many features have, and like Valhalla is a great example for this. Started out as a very performance-centered idea, but really evolved into a space where you should make semantic decisions about your code. You want to make something a value type because you don't need the identity, and then you get performance downstream.
Yeah.
But the lazy one is really more of a, in an ideal world, we just have everything as a, well, maybe not everything as a final field, but lots of these things would just be final field. They would be initialized when the object gets created. But this specifically is a kind of performance consideration, right? I would use a lazy, as you said, when I realize this, I want to do this later because maybe I don't need it, or maybe I don't need it to pay the cost now. Or do you think there's another angle
I think we can circle back to your initial comment on why you use a final field.
Yeah.
Because you said it's not only always about performance, it's about semantics.
Yeah.
And it might be the same case here. Maybe I don't worry so much about performance, but maybe I worry that I only want to create this logger once because I know I configure my logger to create a rotating logger somewhere deep in the file system. And I don't want that to be invoked 100 times because I will hammer my file system.
Yeah.
So that can be another reason.
Okay. Well, that does still sound
it's performance,
adjacent,
but maybe it mutates something.
Yeah.
Or maybe you will make sure that you only run it once. Then it's not a performance issue; it's a semantic decision.
Yeah, although like this lambda though, because I think that's actually the difference to the imperative approach. But correct me if I'm wrong. The lambda approach basically puts me in a situation where when I create the lazy, which will still be during construction, I have to configure the lambda then. So that also means, unless it references like a mutable field, so not immutable, but a field that can be mutated, unless it references that, I have everything, I have all the data already that goes into the computation of that field. It's probably like arguments from the constructor or whatever. In the past, I could really have said, no, on the first method call that passes in some argument, I'm going to create this instance. So I think in the past with stable values and this imperative methods, I could really create it later with more information that I have later.
That is true.
Whether now the lazy constant is with the information mostly, unless I do the hacky path, that is available during construction,
That is true. So that's the other 20% I'm talking about. So we lose, with this more clarity and more, succinct API, we sacrifice this part. But that part wasn't so great anyhow with the added stuff. So I think we will have to come back with something better on that. But of course you can hack it. You can have a mutable field, which you set, and then you invoke that with a lambda. So
and you set the field to null.
Also you can do that. So I actually made a prototype of. I can express all the methods we removed in those stable values using this kind of atomic reference stuff. So we have all the primitives, and you can write a utility method that provides something that we had before. So you can hack around this, but it's not looking good. I can tell you that.
You're right. You can write. I could basically write a wrapper for LazyConstant that is called lazy late constant.
Exactly.
LazyConstant that does the whole.
And it does everything, and it relies on the lazy constant.
Okay, that will be my first JEP proposal then. I guess. I want to get shot down hard.
Yeah.
Okay, Per, thank you very much for being here.
Thanks for having me.
My pleasure. And Devoxx is slowly coming to an end. When we started out the series, I kind of promised there would be a stream on Friday, but I forgot that this whole space is getting cleared out already on Friday. The conference is, there's going to be the first half day of Friday, it's going to be lots of talks. Usually there's very interesting talks midday Friday. So Stefan, the organizer, tries to get people to be here and stay all the way to the end. So tomorrow is a great day at the conference, but we will not have the opportunity to stream. But we have already and will record more interviews. And as I said, we're probably going to publish those throughout the next week together with the talks from Devoxx. So thank you everybody for watching these streams if you did. And I was going to say, and you missed out if you didn't, but if you didn't, you're not hearing this. So I don't know, I'm rambling, it's late. Anyway, so yes, like and subscribe, do the whole YouTube thing, and I'll see you later. Once again, thank you, Per.
And don't forget, stay in the fast path.
Okay, is that your line?
Yeah.
Okay. Okay. See you. Bye.
Bye-bye.